Hello, welcome to episode 119 in this series where I'm programming an NES game, tonight live on Twitch, from scratch. Let's get into what is going on. So last time I fixed the transparency, or at least made it better, in terms of the way that the transparency was detected and dealt with. One thing we didn't really look at too much, and it was because I can't type, not sure how important it was dealing with RGB PNGs, because one thing that's odd is that Photoshop seems not to handle transparency on indexed PNGs. Or indexed images in general, even though sprite does. So I was able to create this guy here. Well, I guess it handles it, but it must require dealing with the channels in some way that I'm just simply not capable of, and I do not necessarily like dealing with that. It would have been easier to just have it be transparent. I don't know. Oh no, I converted it to RGB8, so even though the sprite version, that's interesting. So sprite made it indexed, or did sprite make it RGB8 as well? Interesting. So is that all I had to do, was make it RGB8? Because it doesn't show that it changed the image in any way. Let's make a quick test here, because I wanna just make sure before moving forward that we're not gonna have to revisit this yet again. So if we have a 16 by 16 that's just blank right now, let's grab this green color, and I mean, it doesn't really matter what it has, and I apologize for the background noise, but the dryer is going and something loud is in it right now. So we have transparent background, we have this green and this green, and let's grab one more color. So we have 3 colors in our background, and I made something. And yeah, and so let's save this and see what happens. Export, please, quick. Projects, shooter, assets, PNG. We'll just call this quicktest.png. So that's an RGB8. Also, oh. So it doesn't like this file, even though it should technically be the same. Sorry, Photoshop, that's not what I meant. Please open this. Thank you. Okay, so it's an RGB8. Layer 1, alright. So when we open it up, let's see what happens here. Because I thought it would work either way, because I thought it was re-indexing RGB images to indexed based on what colors were closest to the colors in the NES palette that we're using. But apparently not. Or maybe something about Photoshop and the way it saves it's different. Oh goodness. Visual Studio will eventually attempt to actually run the code. And when it does, it'll tell me my syntax is wrong. Alright, so PNG to sprite. Let's try that again. So image indexed. Indexed. Really? There we go. That was weird. Yeah. Is that really null? So it's null. So interesting. So this only has what, image pics, which is the RGB representation. Certainly looks that way. Alright, so I guess what we need to do then is, and that explains why it's failing, because it doesn't load it in. So I guess while Photoshop is treating this as a RGB8, it really is indexed by the way that, at least based on the way that Sprite is saving it, versus this, which is saved only in RGB format. So let's do this. If image indexed is no, actually, is there some sort of transparent? How would this be? How is this indicating transparency? Oh, RGB alpha. Okay. So we got to look at the alpha channel. All right. So if actually, let's do this here. How do we want to do this? Alright, so let's do this. Let's... Right, so if the transparent index is -1, we know that it's not using index transparency, but also we got to check if image indexed is null, because that means we're not using an indexed image. So if that's the case, then what we need to do is the following. First, we want to just say image indexed equals new indexed. We don't need to allocate a whole new buffer for it, and just here, if image indexed and converted and not converted from RGB. Right, so that's that, and then we can say if converted from RGB, then we say image indexed I, if image pix IA, the alpha is 0, then image indexed I equals 65, not 64, 65, and continue. So if we've converted from if we're converting from RGB and the alpha channel is 0, meaning that it's fully transparent, then we will store the transparent value here. Now, I guess we could use the alpha to determine transparency values, but I don't even know if that's worth doing, because, well, it would be basically all it would be is an approximation of what the image would look like, or what the pixel would look like, transparent, semi-transparent over a white background, or maybe the background color. I'm not 100% sure. It doesn't seem like a use case of something we would support. So it's either all or nothing. So let's check how we're doing here. So it is converted from RGB, so we'll just set that. And then we check pix A at 0, so we made it transparent. Let's see if we get, what did I just do? Run execution to here. Well, I didn't mean to do that. Not sure how that triggered that. Let's try that again. Get rid of that breakpoint. We know that's working. Alright, so what is... It is B8. Okay. And it is not fully transparent, so that's good. So then we do our RGB to YUV conversion and then compare that to the NES palette version, YUV version, and we find the closest match we can. So that looks to be about right. This is kind of unnecessary. We've already got it assigned, but you know, that's fine. All right, so now it actually should have exported something. There it is. And so NES asset tool, quick test.sprite. Interesting. So that's not exactly the way that that's supposed to look. Let's I want to see what it says in terms of colors that it found when I do the export here. Found 4 colors, so that's normal. But that last, that last tile there, it's not correct. And is it just the colors I'm using are no good? Thought I had an pretty sure I had one that was specific for the NES here. I don't know what you're doing. There we go. Thanks. Let's pick some different colors here just to experiment a little bit with how this is doing the mapping. So like the first part of it is right, the top part, but these two, the shape of this one is fine, but the colors are wrong. The shape of that one is fine, but the colors are wrong. Is that because that could very well be related to not so much the export, but rather the way it's handling the palettes. Well, it's only setting the one palette for all of them. I mean, all of that seems good. What about the palette itself? Let's 0E, 24, 26, and 0E. I'm surprised. I'm surprised that it is picking up 0E as another color, because it should be these colors, and 0E, even if it were a background color in use, seems strange. So let's take a brief look here. F878, F8. I assume that would be this at first. F878, yeah, okay, so that's fine. The match index is 24. Let's bring up the NES Dev palette so we can compare in real time. So 24 in hex. Is that pink? Yeah, that's pretty close to what it's supposed to be. So what's the next color it's going to find here? 24. Yeah, so it should be finding 24 for quite a while. Let's add a condition and say image indexed I doesn't equal 24. Let's get to the next color, 26. So 26 is that one, which again is the color. And then $17, which is that color, which that seems right. So all of that so far seems right. Let's check it for any image. Hello. Add condition. Fine. Let's change this. So that doesn't equal that. And image indexed I doesn't equal 26. And image indexed I doesn't equal 17. So it didn't ever get 0E as an option, so I'm confused by this palette it generated, because clearly I wonder if the issue is when it's going back to look at this. So let's take a look at this. So convert image to indexed. We call that first, and then load image palette. This is looking at indexed. I'm just trying to see if it's looking at anything besides indexed, because it's strange to me. Strange to me that we're getting that 0E mixed into the palette that we're using, given that it is not used at all. Load image palette. Wait. Convert PNG to sprite. Convert to indexed. Alright. So we're going to go through. Let's see what it loads into temp palette. We're going through and pulling 24, 26, and FF. Oh, it's because it's only using... Okay, well, so this was actually good, because this is an interesting edge case. So basically what had happened was that we are... oh, man. Okay, so I'm surprised this hasn't come up yet, but basically what it is this is our 8x8, right? And you can see we only have 2 colors here. This is our 8x8 here, only has 2 colors, but, oh, wait a minute, this has 3, and so does this. Now, technically, we should be able to just use the first palette we generate. Yeah, sorry, I'm just thinking this through. We should be able to use the first palette we generate to handle this and just end up with a final palette that has 24, 26, and then 17. I wonder if the issue is... that we are not accounting for that properly. So let's see. Let's I'm trying to think where I want to hit the breakpoint. So that's temp palette, but I want to see final palette too. So right now, the final palette is totally empty because it's only 4 sets of 16, I believe. Sorry, four sets of 4. It's 16 total. Yeah. So every loop through here, we should end up. Yeah. So now we've got 17, 24, and 26, and I think the problem. Okay. So that's the problem. The problem is that we're not properly combining the palette colors and taking advantage of the fact that this first palette we generated only has 2 colors, while this other one we're now looking at has 3. We need to fix that, because we should be smart enough in this code to handle different permutations. Now, I had originally written this to compare the palettes 1 to 1, essentially, and say if you get the same palette. I mean, that's the problem, right? Is that it's a literal match. It's not a combinatorial match where it's, or a permutative. I don't know. It may have just made that word up. It's not checking the combination of colors to check if they match. It's just checking to see, do the palettes exactly line up? And that's why we're getting a second palette that gets generated here. And then the issue is we squash the palette down to just 1, which doesn't work. I think it's actually generating... Well, it's actually only generating the 1. That's interesting, but let's fix this case because this is important to be able to fix. I wonder if it makes more sense to, instead of comparing the palettes like this, compare the individual colors in the individual palettes and just kind of stack them in. And then if the palette was found... The problem is this doesn't work if you require more multiple palettes for the sprite, but we're not even there yet, I don't think. So we're not at the point where we... Sorry, I'm thinking this through and trying to justify a decision, but I think that it's probably the wrong decision to justify here. So I was going to say, well, we could just iterate through final palette, make sure the color we're looking for in the temp palette matches, and if we are, then if it does, then we're good. Otherwise, put it into the final palette, and then we should be good to go. The problem is that that really doesn't take into account. That doesn't really take into account the allocation of the colors. So if we have this here that's got one set of colors, and this here that's got a second set of colors, but there's an overlap, the real issue is that if we have one palette that has colors A, B, C, and D, we have another palette that has C, A, E, and F, we can't combine. These are not combinable because obviously there's more than just the three colors. I mean, ignore this color. I don't know why I still even bother calling that out, but there's combinatorially, or in sum, there are 6 colors between the two palettes, even if there is a shared, well, there isn't in the way I have it now. Let's say that B is shared. Sorry, my drawing sucks. If B is shared, but then you have E and F, there's no way to combine those. But in the case that we have here, what we basically have is we've got BC and nothing, and then BC and D, and so we can squash this down to background color B, C, D. So how do we do that? How do we make our code do that? Because what we're really saying is let's see. So it depends on palette count, I guess. Yeah. Yeah, so what we'd have to do... Where are we actually executing code right now? Oh, we're down here. Forget, does Visual Studio let you run backwards? Can't rewind here, can you? Okay, let's rerun this again because it's worth stepping through this and looking just to make sure that I'm thinking about this the right way. So here we see that the palette count, that's not what I wanted to do, is 3. But why is it 3? Because it should only be... Yeah, it's just 24 and 26. What are you talking about, load image palette? Do I have an off by 1 problem here? Because what I was thinking we could do is we could say, all right, count how many... we have our palette count. Look at the first final palette and figure out and keep track of how many in the 4, we have those 4, right? Sorry. We have 1, 2, 3 full palettes that we're keeping track of, and keep track of, okay, this has 1 free, this has 3 free, this is 3 free, this is 3 free. Look at this and go, okay, how many colors are we? Hey, Blimman, how's it going? Look at how many we have free here. Find out how many overlap, and then compare and say, okay, if we've got 2 that overlap, and that we had 3 colors, so there's 3 colors and 2 that overlap. That means we have 1 left. How many spots free does this palette have? It's got 1 free, so we can use that and add that 1 color. If this were 0, then we'd know we'd have to jump to that next palette, which has 3 slots available, and that would effectively manage our palette overlaps, I think. So, thanks for joining the stream, Bleman. Am I saying that right? Bleman or Blehman? I don't know. Bleh. Let's look at this palette count, though, and make sure that we are getting an appropriate count here. So, color count is 0, and we're skipping the background color. Yeah, it is off by 1 because it's counting the background color for our final color count here. It's going to say 3, but really it means we have 2 colors used because the background effectively doesn't, well, it could count, maybe not. Is this a game that could run on an NES or an NES-like game? This is actually a game that will run on the NES. I've got the assembly code here. Right now, I'm trying to fix up my code that's turning the PNG into something the NES can handle. I'm just working out the background transparency situation because it is problematic, and I want it to work so that I don't have to hard code colors as transparent colors or anything like that. I could just use transparency for real, which will make it easier to use in things like Tiled that handles the transparency as it should. So yeah, if you want to see real quick, this is an emulator running the running some of the code right now. But I'm still working on stuff here. All right. So realistically, this should return. Nope. Go back. This should return color count -1. Because the background doesn't count. All right. So if we go run this again. Or should I take into account, should I not do this and, you know, let's not do that because I'm worried that that may have impact somewhere else that I'm not thinking about. So let's keep that at 3, and we'll just treat it as if there were 4 independent colors, knowing that the background index 0 doesn't matter. So now let's fix this part here. Oh, I didn't look at the palette count. I think it's still 3. It's still 3, right? Right. Okay. So what we need to do then is let's also keep track of, so that we're not recalculating this a million times, let's keep track of how many colors are used in these final palette sets. And there are 4 of those. Guess I could have done this, can I? All right, so just to make sure that that didn't break anything. It didn't do the initialization I wanted. Okay. I knew there was a reason why I didn't do it that way. Fine. This is just 4, so we'll hard code that like that. All right, instead of doing the mem set. So now, let's comment this all out for a minute here. What we want to do I think I actually want to comment out this whole loop here because it's not correct. All right, so what we need to do is we need to check how many colors are in any of the given palettes. So we will exit the loop as we need to if we find a palette that will suit our purposes. And so we will then loop through each individual palette and say if, let's create something called matched palette count. If final palette, come on autocorrect, or autocomplete I should say, times 4, plus j. So if that is equal to so this is pretty ugly with the nested loops here, but as we've said before in some of our other code that is similarly ugly, this code is not about performance, this code is about accuracy, and the data set size that we're operating on here is so tiny that while I would never accept this as an appropriate solution in something where we are processing a large amount of data, in this particular case, because we're dealing with such small numbers of pixels, this is okay. So final palette I shifted twice plus j is temp k. Okay, so if this is equal, then we're going to say matched palette count plus plus. So we're there. So we've let's think about this. So this actually I just got to make sure I'm doing this right. So we're looping through all the colors in the final palette set that we're looking at and the temp palette and comparing, and then we want to see if we've matched everything. So if matched palette count is equal to palette count minus 1, because we know that the palette count will include the background as a color And so we want to make sure that, what are you complaining about? Oh. Yes, I don't want to compare it against a pointer. Thanks. So if the palette count compared to the matched palette count is equal, that means we found what we're looking for, right? And we can just say and that's it. That's actually, we're done, right? So we break out of this. You know, we don't want to do that here. We want to do that here. So if match palette count, so if we loop through all that crap and find that we have matched all the colors, then we're done. So have we matched all the colors in temp palette with final palette? Yes, use final palette sub I, right? That's final palette sub I will be our final palette that we want. Let's see. And then we've got to set palette. That was the other thing we had to do. I knew there was one more thing. So found palette index is equal to I. Not compared equal to, actually assign equal, please. Alright, so if palette found, this is no longer necessary either. So, re-index the image tile based on our final palette using found palette index, which should be set in a... Okay, we have the case where we match 100%, so that's great. If we don't match 100%, then we have to look at the matched palette count compared to how many palette values are still open. If matched palette count if 3 minus matched palette count is greater than let's do this. If it's less than or equal to, what do I call that? Final palette free I. Let's put some friends. Okay, so if our match palette count is going to get subtracted from 3. So whatever that count is, if it's less than or equal to how many spots are free in the final palette free for that particular palette index that we're looking at, then we can add the ones that don't have a match. And then we're back to some awful loops where we say j is 0, j is less than 4, plus plus j. I feel like we could do this better, but again, I don't want to spend an hour and a half optimizing something that's going to operate on 16 values at most every time. So for int j is equal to 0, j is less than 4, we increase j, and what we're doing is if temp palette j, let me think about this. equals. How do we do this? How do we do this? We actually, first of all, don't even want to start at 0. We want to start at 1. Well, no, sorry. For this, we want to start at 0. For this, we're going to start at 1. Same thing here. So j is equal to 1, j is less than 4, plus j. So let's think about this. The palettes that get generated are going to be compact, meaning we're not going to get situations from the way that the code is looking up and generating the palettes. In temp palette, we're not going to get situations where we've got a blank one, a good one, another blank one, and a good one. They're going to be kind of all good until the point where we get that, right? So if there's just one color, we'll get this. So basically, what we want to do is we want to say if temp palette is equal to final palette I2 plus K. Shit. Oh, excuse me. Sorry. Damn it. I didn't mean to curse. All right. I'm all flustered. All right. So we've got that. So if that's equal, break, because that's not the one that we're trying to put in, right? So we're done with that part of final palette. We're going to go to the next one. So if it's not equal, if we then only want to do something if final palette So we only want to replace a value in final palette if the value is set to -1, which means it hasn't been set. And then we're good. We can break out of this part of the loop. Go back to this. And then we should be good. And we can say found palette index is equal to I and break. Yeah, these nested loops are cringy, but they should get the job done. We have lots of loops in here. So let's take a look at what this is actually doing now. That's interesting that I am doing this initialization like that there, which is not working the way I expected it to. Should probably fix that. Okay. There it is. Okay. So palette found can probably go away. Found palette index should not go away. So temp palette now has 2 colors in it. Palette count is still set to 3, which is technically true because it's the background and the palette colors that we need. So now we go through sort of the long, cringy process of matching colors up. Final palette. Oh, you know what we should probably do? Also not bother checking if the value is -1. Because we know that that's not actually a color we plan on using. So if temp palette k doesn't equal -1, and so we'll just short circuit that whole test, right? Because what will happen is we'll check this first, and then if that's -1, it doesn't matter if this matches or not. Let's try that again. Okay, so we should get no matches. Let's get rid of that breakpoint. Match palette count is 0. And palette count -1 is going to be 2. Then we did not get an exact palette match. And so match palette count is 0, so there should be 3, and final palette free. 0. Well, that was dumb. I shouldn't have initialized it like that. What I meant to say is that they are all free. None of them have any free spaces available. Why are you not formatting for me? Not important, just annoying. Alright, so match palette count is 0. So temp palette J equals final palette K. So it didn't match. And that is -1. So let's take a look here at our colors. So we should be setting this element here to the first color, which is 24. We did. And then we set final palette free down to 2. Great. Skip the next entry there. We'd set that to 26. Great. Yeah. I forgot to do if temp palette J is equal to -1, continue. Actually, we can just break because, again, they're compacted palettes, so if we hit -1, we're done. It's not like there are gaps. Okay, cool. So let's put a breakpoint there. Come on, final palette. Temp palette. Thank you. So we should get 24, 26, and then we should stop. And we did. And we are done. We got found palette index is equal to I, which is 0, which is great. And then we re-index that. And then we're going to do it again for the next one, which is going to get a palette count of 1, which is right, because if you look at it here, it's just... Oh, is it just 1? Palette count. Oh, I'm looking at the wrong thing. Okay, it's 2 again. Okay. So that's good. So let's So far we're doing good. We're matching palette colors. Oh, you know what? We should break. We should not continue checking once we found the match, because that's dumb. Match palette count 2 so far. Okay. Match palette count is 2. So in this case, the palette matches perfectly for us. So we can break out and re-index the tile with that palette. That is brilliant. That's exactly what we wanted to do. And now we're on to the next row. And we get the palette count, which is 4. So there are 3 colors involved there. There's this pink, this orange, and this dark orange. So let's now look at how this behaves, because this is our edge case that we were coding for here, where we get, we can even break here. If we get -1, technically we could break, but I'll worry about that in a minute. So match palette count is 2, palette count is 4, which will yield us 3. So match palette count is 2. So we need one. We need one palette free spot, and we have one. So now we just have to find the color that isn't already in the palette. And there it is. Just want to look at this for a second. Oh, it just happens to be the first one that's in there. Cool. And then we will go through the other ones and make sure that they are actually already in here, which they are. We have our new palette, and then we re-index the tile, and then we're gonna do the same. It's gonna do the same thing. So now we should end up with something that looks correct. Yes, that is exactly right now. That is awesome. All right, cool. So we actually fixed that problem. So now it's properly consolidating the palettes down so that we get the 3 colors into one palette entry there. So now, if we do, we shouldn't see any major difference here, but I'm curious to see how this behaves. Oh, well, it's because we already have the palette defined. Let's regenerate that palette. Okay, and then do that with the newly generated palette. And there's our ship with the bounding box and the right colors. So that all still looks good. If we wanted to do something, we could do something like that and change the background color just for fun, but obviously has no meaningful impact. All right, cool. That is excellent. So let's go into tiled. Let's create our tile set for our little bit. And this will be one of those little kind of throwaway enemies that you get in every shooter that you get to just kind of fire a couple quick fires and it gets destroyed with one hit. Where did he go? There it is. Okay. Save as tile sets, little bit. And then let's export that as JSON because we will need that. I don't... How come I didn't actually see the image? Where'd you go? Little bit. Little bit.png. Oh, there it is. It's up in the top corner. I didn't see it. It's so small. Alright, so let's get rid of... Don't need bumper, flyby. We need green tile. Yeah, we want green tile and water. So let's add our tile set for a little bit. Add external tile set. Where you do a little bit. Okay, there it is. And we gotta go to something. One of these days I will actually remember on the first attempt how to use this thing. There he is. Okay. Let's just create a line of them. Just because it'll be cool to see that. And we may want to modify the behaviors at some point. But for now, I'm just going to make it fly straight down the screen. And we're just going to add a whole bunch of them. See what the game does. I know what's going to happen with the sprites is they're going to look not so good. So actually, we should stagger those. You're going to let me select them, please? What's with that? I'm confused. Why is that grid moving too? I'm moving the whole object layer? That's not what I want to do. I just want to move that guy. Offset layers. Oh. Well, I guess it helps if you use the right tool. There we go. Let's, we're going to, I like the idea of having them all in a line, but the problem is we're going to have too many sprites on the same horizontal. I mean, we're going to have that anyway, but let's kind of minimize this as best as we can, because I don't think the Flickr code is working right now. I think we got rid of that at some point, or not got rid of it, but we broke it when we separated enemies into, we separated things into objects and projectiles. So more than likely what's going to happen is that they will not all display, but we'll see. So NES Asset Tool, if I can spell, export. Shooter.json. Right, that's our project file now. Yep, so we've got bullet player, cloud, enemy bullet. We don't need low altitude or medium anymore. We don't need bumper anymore. because I got rid of that from the map. Okay, and then we need palettes. We have player. This should be little bit pal. Actually, we should probably make it conform. Well, whatever. We can change that. We can. We want to make this conform, but it's not really that important. So, we're not important enough right now to derail what we're about to do. So, okay, so that exported in theory. Let's, this is going to break some of the code because we're going to be replacing some things where we got rid of some of the items and some of the enemies and stuff. So we're going to see things like, yeah, so low altitude projectile not referenced. Let's fix some of this stuff. So this is no longer needed. No longer needed. No longer needed. Okay, so this does not exist anymore. So that can go away. Process flyby. And I mean, we can actually just get rid of all of these because these were just test things that we were doing. Not particularly good or useful. Medium. Low altitude projectile.asm is still included. No. Check bullet collision. Line 18. Load type, check that, boom, okay. Process LAP, where is that? 1455. Oh. All right, so the good news is we've got this stuff taken care of. Now we need to handle the new entity. So compare entity type to little bit, and if you go to entities, you'll see little bit got defined. That's cool. That's what it's supposed to do. So let's compare that, and branch if equal to L process little bit, and L process little bit, and then jump to L process. Sorry, just process little bit. So now we got to actually define that thing. How did we do this in others? Did we add scopes or we just did the process? Okay, we just did the process. So let's do that. Process a little bit. Break. What is it supposed to do at the end? I don't even remember. Not break, that's for sure. Jump entity. That's a projectile. I think it's just jump entity object complete. Process little bit is undefined. Oh yeah, because it's not included. dumb. Okay, so that's that. And then the only other thing is we got to check. Just steal this code here. Check if it's a little bit, and then process the collision. So let's see how badly broken this is. At some point we should see the enemies appear. And that point should be coming up soon here. They're not going to do anything, but they should appear. And then we should be able to also destroy them potentially. Okay, so they're not here. And that's no good. Why? Add map object, something like that. Oh, I'm on the wrong file, that's why. Stop. Add map object. Object confirmed, increment enemy index, jump subroutine, add map object, but that should have the type in there. That's the enemy type. Okay. Add map object. So why are you not adding that? Draw entities. So it is there. Let's go back and let's go back and run our Lua script. Kind of interesting that it's playing some sort of audio there. I guess I didn't completely disable the audio. Not memory. This. I want to look at the entities that are loaded. So we should see. Oh, we do. So it's loading them up, but nothing is being drawn. Are we... Sprite viewer. So it's there. Are we exceeding... We might just be exceeding our sprites and it's not drawing properly. Let's see... I'm okay with that. I would rather that's the case than anything else. Where can you turn on the extra sprites? Thought it would just be an emulation. Video, picture, general, scale, picture, overscan palette, advanced, remove sprite limit. Sure. Okay, well, it's still not drawing them. Oh, you know what? They might be off screen. Thinking about this. If they're being placed just off screen, which they're supposed to be, yeah, you can't see them. All right, so let's implement the code to process them, because that's ultimately what the problem is. So let's just increment the Y position. Load A. X has the offset. So, sorry, I'm just trying to remember how we organize this projectiles. So this would be objects plus entity Y position X. You know what? We can just increment it, can't we? we're not doing anything other than trying to make it move down the screen. So let's just increment it and be done with it. So there, and run our Lua. Now they're going to move down the screen pretty fast and also wrap around. There they are. So the question is now, actually probably don't need the removed sprite limit. Well, we do. Okay. I mean, the good thing is we'll need to fix our flicker code. And I can't tell if what I'm seeing here is that's looking okay. All right, so let's do this now. Let's load A, clear carry, add carry, 1. And then we want to compare it to 240, which is some value in hex that my brain refuses to remember. F0. Compared to F0 branch if not equal to there, which means we're done. Store A into, oops, into there. Otherwise, we're going to load A with entity type, right? It's entity type no entity. Yep. So we're going to load it with that, and then store A objects plus entity type. I don't remember what my things are called here. Yes, just type. Store it into type X, and that will remove it from the list of objects. So simple enough. Let's see if that behaves the way it's supposed to, so that they get cleared out when they hit the boundary of the screen. So far that looked good. They don't collide with the player yet. We'll fix that later. Should be able to shoot them though. That was interesting. Not sure exactly what that was all about. Let's see. I mean, that looked normal. So let's see. Oh, it's just because of how many sprites we have on the screen right now and the flickering. I thought what was happening is we were getting like sprite swaps from something that was broken, but it actually looks like it's just we have so many sprites right now. Without the flicker, we're losing pieces of things. Okay. And let's make it so that they can collide now with the player, because that is a thing. So let's see. Where... I think that's in the player code. Check collision loop. Load a... player collision loop. This is used for shifting. Okay, check player collision with the map. Oh, that's with the map. That's not what I wanted to check. I want to check with objects. Where is the... repeat scroll. But that's all background collision. Where is... I think it's maybe even just in a check player collision or something like that. I don't remember. Draw entities, enemy stream, explode, gradient, MT collision, player collision. No. Scout, shooter, test sprite. How are we doing it with this guy? No, not that guy. That's not code. Low altitude. I'm in the wrong. I'm looking in the PNG. Oh yeah, check player collision. That's what it is. So save off the registers, skip player, compare, skip that. Load, compare, branch of equal, jump. Did I get rid of, let's take a look, because, excuse me. I can't remember if I changed this file or not. It doesn't look like it. Check bullet collision. I changed because that was checking to see if it needed to collide with those things like the enemies. So yeah, so that's not how... Is it enemy collision? Maybe that's where it is. Enemy bullet. I can't remember. Check collision. Oh, right. Sorry, it's been a while. So we want to... We added these medium ones, and the medium code makes a call to check player collision. That's what we need to do. So, before we are done, but we shouldn't do it. It shouldn't collide if the thing is a no entity. entity object complete. Okay, that will solve that. All right, so now the little bit thing should collide with the player. And we don't need that anymore. Actually, let's relaunch this because sometimes it just needs to be relaunched. It runs smoother. Okay. So should still be able to shoot them. And what? We probably do that there. Check player collision. Why did you not work? Let's check bullet collision. Don't need that. Don't need that. I want that. Entity pointer contains the address of the entity. Oh, I guess because I don't know how to use my own code. All right. That's the thing, you know, you do this only like twice a week. It's really easy to forget how these different pieces work. And then you make ridiculous mistakes. Okay, so let's get those to spawn. That worked, great. And yes, we have collision. Okay, cool. Well, let's call it for the night because we accomplished a lot and it's not super late for a change. And yeah. So, as always, thank you for watching. If you want to reach me on Twitter, I'm at Clervis. I'm Xelius, Xelius, on Nintendo Age in the Discord as well. You can reach me through my email at xelius@gmail.com. Also, this is recorded, so if you want, you can post a comment on the video on YouTube. Feel free to subscribe to the channel. I've got about 1,100 subscribers at this point, which is pretty awesome. Great to see the interest growing from people on this project and NES programming in general. And yeah, I'll see you guys next week on Monday, and have a great weekend. Take care. Thanks for watching.